Okay, so this is the video that will go through the non-calculator active problems on the midterm review. Alright, so at first we have number 6 is the first one, and we're going to determine even or odd. So even or odd has kind of two definitions here. Even or odd could mean that all the exponents are even or all the exponents are odd. It can also mean that the graph has y-axis symmetry or origin symmetry. So we can look at something graphically or we can look at something algebraically. So for number 6, for actually number 6 and number 9, I'm going to look at both of these graphically. So I have x squared minus 4. I know that's a parabola that's down 4, and it looks like this. This has y-axis symmetry. This is an even function. This also is an exponent of 0 in this x that's not here, so these are two even numbers, 2 and 0. Similarly, number 9 is an upside down v, and it's moved up 1. So that also has y-axis symmetry. Then when we go to 7 and 10, those are both shifted off of the origin, so they're not going to have any symmetry. X minus 4 squared is a parabola shifted to the right 4. This has no symmetry at all. It doesn't have even symmetry or origin symmetry. And number 10 is similar. So this is a upside down absolute value that's shifted to the left one. And so this also has no symmetry. So both of these functions would be considered neither. The last one, we can strictly look at the exponents, because maybe we're not sure what the graph looks like, although we could factor out an x, and we would get x squared minus 2. So this is a polynomial that has zeros at 0, the square root of 2, and the negative square root of 2. And given what we're learning in class right now, you know that the end behavior is up, down. So the function just curves through these 2 points, and you can tell that the function is a reflection over both the y and the x-axis, so it actually is odd. It does have origin symmetry. If you didn't want to factor and get that, you could look at the exponents. This is an exponent of 3, this is an exponent of 1, they're both odd, therefore it's an odd function. Okay, so when we get to translating with even and odd functions, if I have a point -1, -2, and it's on a graph, so here's -1, -2. If I want this, so this is my original point down here. If the function is even, then the point has to come over here. So that means that I'm going to change just the x coordinates. So for an even function, I want the point to be 1, -2. If the function is odd, like it asks for in number 12, then I need the point to be reflected this way and up. So actually I need to change both signs of this point, so I'm going to change it to 1, 2. And lastly, 13 is a translation, so we need to operate on the x and the y's separately. So this is like order of operations. So I'm first going to take y and multiply it by -2, so that's 4. And then I'm going to add 3 to it. So that takes my y to 7, and this means right 1, so I'm actually going to add 1 to this and get 0. Okay, equation of a line. So you want to stick with the easiest form of a line, which is point-slope form. And this comes strictly from the slope formula. If I divide both sides by y minus y1, if I divide both sides by x minus x1, you notice that I get the formula for slope. So this is very useful and very easy to use. So when I find the slope of 4x minus 8y equals -16, I will just do negative a over b, so that's -4 over -8, that gives me 1/2. Then in 15, I want a line that is parallel to this, so that means I'm going to use that slope, and through the point 1, 3. So I can just use this formula and leave it at that. So y minus y1 equals m x minus x1, and that's all you need to do. You don't need to simplify it or put it in any other form. 16, we want to do undefined slope, so anything of x equals is undefined slope. That's because I'm rising forever and I'm running never, so I'm dividing by 0 on the slope. So if I'm passing through the point 1, 2, then x will have to equal 1. That would be my line. For 17, if my line is y equals 2x over 3, then that means my slope is 2/3, so a perpendicular slope would be negative 3 over 2. So the next part is solving quadratic inequalities, and that really comes down to, can you sketch a parabola? That's all you really need to do for these. So when I'm looking at something like x squared less than 4, I want to treat this like a parabola. So I want to ultimately get 0 on one side and find the zeros. So let's just look at x squared minus 4 and see if we can graph this. This is a parabola. It's shifted down 4. And it has zeros at 2 and negative 2. And I get that by just solving x squared minus 4 equals 0. So the question is, when is this parabola less than 0? So I look at the x-axis, I cut it in half, and then I go less than 0. So that's between negative 2 and 2. On 19, we're going to have to factor, because we don't know the zeros. So I'm going to subtract 2, and then I'll use master product. So I'm looking for two numbers that multiply to negative 6, and add to negative 1. And then I'll group each pair. So I get 3x plus 2, and x minus 1 is less than 0. So I can get a quick sketch of this parabola also. This is a parabola with zeros at 1 and negative 2/3. When is this function less than 0? Between negative 2/3 and 1. Nine minus x squared is going to be quite similar to the first one, but the parabola will be upside down. So 9 minus x squared, and we want this to be less than 0. That's an upside down parabola. It's shifted up 9, and upside down has zeros at negative 3 and 3. And I want to know, when is it less than 0? So I'm looking at from negative infinity to negative 3, and from 3 to infinity.